All right, so let's have a look at this one because it sets up a bit differently, okay, than the ones that we've done previous to this. So we have a ball that's thrown into the air. Okay, we know it's thrown at 35 meters per second. So that's the projected velocity. It's not the vertical, it's not the horizontal, it's the projected. So it's the hypotenuse, okay, of this triangle that we've been using, okay, all along here. Okay, so we got V horizontal on the bottom, we got VI vertical on the side. This is our angle, but it's unknown. Okay, at this point. So this always leads to, okay, the projectile arc that we've been dealing with. Okay, that triangle is always going to be the same for all projectiles. So what this question told me is that this thing was in the air for 2.5 seconds. I know the acceleration is negative 9.81 meters per second squared, and I know that it travels 70 meters horizontally. What can I calculate right now? I can calculate V horizontal because horizontally it's going to travel at a constant speed. And I have the distance and I have the time. Okay? If I can get this side, can I calculate the angle? That's the realization. I can get two sides of this triangle. Okay? Then I calculate V equals D over T in a trig calculation. Right? So V is going to be 70 meters divided by 2.5 seconds. Okay? So 70 divided by 2.5 gives me 28 meters per second. Okay? And now I can use that in a trig calculation where I have the adjacent side and the hypotenuse. So that's going to be cos to the minus 1 of 28 over 35. All right, so this was fired at a 37-degree angle. Okay, or thrown at a 37-degree angle. All right, everybody kind of follow what I did there? Okay. I don't give questions very often where I give the time, simply because looking for the time is usually harder. Okay. The problem was I put this on a unit exam about 9 years ago, and everybody bombed it because I gave them the time, and they're like, well, what the hell do I do with that? He's never given us the time before. Okay. Aren't I always supposed to find that? And they just stalled. They couldn't figure out what to do, even though there were really only 2 steps to finish the question. Okay. All they had to do was think trigonometry and go, oh, right, I can get this side. And then I just find the angle. Okay. But they just couldn't get past the fact that they were given a slightly different set of givens than they had been. And they just stalled on it. Okay. So that's why I'm showing it to you, because I want you to understand there's lots of different situations and lots of different starting points for projectile motion questions. And we got to be able to kind of work with all of them. Okay. Rock was thrown into the air. Okay, this one's hard. I'll give you that. So this one's thrown, okay, at an angle. We don't know what the angle is. We also don't know what speed it was thrown at. All we know is that it traveled 30 meters in 10 seconds. I will tell you this. It landed at the same height it was thrown from. All right, so we still have this. We still have the arc. Okay, we know that this distance here is 30 meters. Right? We know that that takes 10 seconds. So again, we've got the time, okay, 10 seconds. Horizontally, we know the distance. Okay, and vertically, we know the acceleration. We're looking for this, and that includes the angle. This question, I will grant you, is a bit of a math trick. Okay? You need to think about something that is here and here that is the same. And then it's a math trick from there. I'll give you a little bit of time to see if you can figure out the math trick on this one. So once we look at the setup, here's what we have to realize. We have to know what to look for in this question. I need the hypotenuse and I need the angle. The only way I'm going to get that is by having the two sides of this triangle. So I need to know what VI is vertically, and I need to know what V horizontal is. I can calculate V horizontal right now because I have the horizontal distance and I have the horizontal, or I have the time. Okay, so all I have to do is go 30 over 10, okay, and I find that V horizontal is 3 meters per second. Right, so that part was easy. I know this side here is 3 meters per second. The trick is in getting VI, because I only have acceleration and time. Okay? All the formulas that we have involve using either distance, which I don't have. I don't have a vertical distance. Well, I kind of do actually. What's the overall vertical displacement? 0. So I could theoretically do this and go d equals vi times t plus 1/2 at squared and solve for vi. I could do that, okay? Or I could also, and this is the way I've done it, is say this: a equals vf minus vi over t. Because vi and vf they're the same. It's the same number. This isn't two different variables. What this really is, mathematically speaking, is that a equals negative v minus v over t, which is negative 2 times v over t. I know a and t. I can solve for v. It's a math trick. Okay? And that's what stumps people on that one, is they don't realize, oh, right, they're the same number. That means there's really only one variable, not two, that I have to find. Okay? I can find one variable here. So what I do is I have a times t, essentially over negative 2, and that will give me v. Okay, that'll be vi and vf, but I really only need vi, and then I can plug it into a trig calculation to get the angle, and a Pythagorean theorem calculation to get the projected velocity. Okay, so if I take my negative 9.81, okay, and I multiply that by the time, which was 10 seconds, okay, and then I divide that by negative 2, right, I'm getting that my initial velocity is 49.05 meters per second up. Okay, now I have the two sides of the triangle, so it's obviously they're very different. Okay, this thing was thrown almost what? Almost straight up in the air. So actually, I think you had done it. I think, yeah. Okay, I just looked at it and didn't register. Okay, so what I have here now is that I can calculate first off the projected velocity. So I'm going to go square root of my answer squared plus 3 squared. All right, so my projected velocity is 49 meters per second. Okay, the angle is going to be 49.05 over 3. All right, so it's 86.5 or 87 degrees. So they threw it almost straight up in the air. Okay. Now that you see that, it's like, oh, right, I only needed one thing, right? Like, it's a math trick. No, I wouldn't guess. I want to know whether you can do, like, understand projectiles, not understand a math trick. This is more, in my mind, this isn't a projectile motion question. This is a math question. All right. Okay, so this is a question that's a little bit different than what we've done. This ball rolls off an incline. Okay, so the ball is here, and it's going to roll off this incline. The fundamentals of this are still the same. There's just one realization you have to make in order to get this question correct. Okay, everything else is the same. Okay, as a projected at an angle projectile. This is still a projectile projected at an angle. It's just that the angle is downwards. Okay, so remember this is a bit of like math geometry here, okay? But your kind of law of similar triangles. If this angle's 30, what's this angle? Okay. Okay, is this the same triangle we've been working with all along? If I do this to it, yes. Okay, it's just in this case, the object is projected slightly downwards. All right, I'm gonna give you a few minutes to see if you can figure the rest of that one out. All right, this triangle is no different than the ones that are projected upwards. Okay, this side here is still V horizontal. This side here is still VI vertical. It's just now VI vertical is going to be negative. That's all that changes. Everything else stays the same. Okay, all the other methods are the same, except this is projected slightly downwards instead of slightly upwards. All right, so what we're going to have here is, again, that our acceleration is negative 9.81 meters per second squared. That doesn't change. Okay, VI is still going to be the sine of 30, okay, times 12 meters per second. This side here is, okay, our projected velocity. All right, so that's going to mean that this is negative 6 meters per second. All right, we're told, okay, that it lands 1.4 meters from the incline. All right, so that's a horizontal piece of information. Okay, and we can calculate V horizontal here at the same time. So that'll be the cos of 30. So cos of 30 times 12. All right, so we're looking at 10.39. meters per second. Okay, so we're looking for how far above the end, above the ground is the end of the incline. So we're looking for the height. In other words, what's the vertical displacement here? All right, so I need one more piece of information for the vertical part of this, either VF or T. Not going to be VF because I have no way to calculate that right now. Okay, but I can calculate time. All right, so that's what I'm going to calculate. I'm going to find the time using these two pieces of information. T equals D over V, 1.4, okay, over 10.39. Okay, so it's going to be a very small time, right? It's not going to fall very far, which means this table's not very tall. Okay. Whoops, wrong button. Okay, so we got 1.4, okay, divided by our answer there. Okay, gives us a time of 0.135 seconds. Okay, now I can bring that over here. And I can use this. D equals VI times T plus 1/2 AT squared. The key here is I have to remember VI is negative. All right, so when I plug this in, I'm going to have negative 6 times, sorry, 0.135, right? That was 0.135, not 1.35. 0.135 the time, plus 1/2 times negative 9.81 times 0.135 squared. All right, so the table is 0.90 meters tall. Okay, I think we only have two significant figures here, right? Yeah, we only have two significant figures. So the table is 0.90 meters tall. Okay, I know the answer came out negative, and it should, because the displacement of the object is negative. It's downwards, right? So it's okay that that answer came out to a negative number. Right? I don't necessarily have to write it that way unless I want to say the displacement of the ball is negative 0.9 meters or 0.9 meters down. Okay, it doesn't really matter. All right, everyone following me on that? Okay, so really not much different than if it was projected upwards. It's just in this case, I can't make VI and VF equal, right? And that's fine. All right, so I want you guys to try a few here from the book. Okay, actually, let's say try this one for right now because we'll try 1 and 2. I'll put them up here on the board and then we'll see how that goes. Okay.